In section 9.7, we'll talk about two different types of special right triangles, 30, 60, 90 and 45, 45, 90. The first one we're going to talk about is 30, 60, 90 degree triangles and what the proportions of the sides are to each other. Now, how this is kind of determined is if you think about an equilateral triangle, and let's say that we create an altitude from this triangle, which creates two congruent triangles and a 90-degree angle. Now, we could say that this side is x, this side is x, and this side is x, and this would be half x. And because this creates a 90-degree angle, we can actually use the Pythagorean theorem to find the missing side. We'll call it y. Now, so we don't have to deal with a fraction within this equation. Let's just go back and change each of those sides to x, making this half right here simply x. So now we're looking at the equation x squared plus y squared equals the quantity 2x squared. If I solve for y, I'll get 4x squared over here. Y squared equals 3x squared. We're going to take the square root of both sides and get y equals plus or minus the square root of 3x squared, which equals plus or minus x square root of 3. Since the distance cannot be negative, we know that the distance right here will always be x square root of 3. So, what this tells us now about a 30, 60, 90 degree triangle is that the proportions will always be x to 2x to x square root of 3. You can clearly see from the diagram that 2x will be opposite that 90 degree angle. And if you think about what an equilateral triangle is, the 60 is here and the 30 is here. So x will be across from the 30 and the x square root of 3 will be across from the 60 degrees. And that brings us to Theorem 72. The other special triangle we'll be talking about is a 45, 45, 90 degree triangle. Now, in a 45, 45, 90, you know that this is an isosceles triangle because the proportions of the angles are in relationship to the sides. So this side and this side will be congruent. So let's just say that is x and x. And we want to see what the hypotenuse is. Again, we'll use the Pythagorean theorem. And to solve this, we'll get 2x squared equals y squared. We'll take the square root of both sides. So it's plus or minus x square root of 2. And again, because the length cannot be negative, the proportion of the hypotenuse in a 45, 45, 90 triangle is x square root of 2. Let's look at a couple examples of how you might use this. If we look at number 1, you see that the angles are congruent and it has a 90 degree angle. Since the angles are congruent, that means that the angles must be 45 45, 90. And what you know about a 45, 45, 90 is the relationship is x, 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 square root of 2. So, if this side is 7 square root of 3, this side has to be the same as this one, so we'll fill that in as 7 square root of 3. And this hypotenuse is x square root of 2, so we'll substitute in 7 square root of 3 for the x, drop down the square root of 2. Therefore, the hypotenuse would be 7 square root of 6. In this diagram, we can see that this will be a 30, 60, 90 triangle. And the 30, 60, 90, the side opposite the 30 is going to be x. The side opposite the 90 degrees, the hypotenuse will be 2x. And opposite the 60 will be x square root of 3. So in this case, 5 corresponds to the x square root of 3. So we can kind of set that to each other. 5 equals x square root of 3. If we solve for x, we rationalize, x is 5 square root of 3 over 3. So then we just do some substitution. We know that x is here, so we'll go ahead. 5 square root of 3 over 3 for this length. And up here, we know it's 2 times x. So that will be 10 square root of 3 over 3. Looking at example 3, we see that again it's a 30, 60, 90. So again, if you need a little reminder, in a 30, 60, 90, across from the 30 is the x, the hypotenuse is 2x, and across from the 60 is x square root of 3. Now, if we look at the bigger triangle, you'll notice that we have 30 and 60. That means this has to be 90 degrees. And the 6 is across from the 30, which means it's an x. And that means the hypotenuse is 2x. So 2 times 6, which will be 12 for the full length. And you can either do the Pythagorean theorem or a simple substitution for the length over here of x square root of 3, which would be 6 square root of 3. But what about the altitude length? If we look at the altitude and we look in here, you notice that it's also a 30, 60, 90 degree triangle. And that should make sense because what we've talked about before is that if we have an altitude in a right triangle, all 3 of the triangles are proportional to each other. So looking at the green triangle now, 6 is no longer x. 6 now is 2x, meaning that x would be 3. And this length right here is x square root of 3, which would be 3 square root of 3. So this length in here is 3. From here to here is 12. Now, by basic subtraction, we can figure out that this length from here to here would be 9. But again, remember that these are all proportional, so this is a 30, 60, 90. And you could set it up to solve for the 9 as well. In this case, 3 square root of 3 is opposite 30 degrees. So that would be x. And the leg would be x times square root of 3, which would give you 9, which is what we saw when we subtracted it.